Hello everyone, and I welcome you all to Study Room. I am your mathematics teacher and my name is Megakshi Rana. Today I will be teaching you the chapter number 16 of class 8 mathematics, and the name of the chapter is Playing with Numbers. It's a very fun and interesting chapter and you will get to learn a lot of things. Let's begin. So what do we have? First of all, we have numbers in general form. So do you know how do we write numbers in general form? See, if we have any two-digit number AB, we have a two-digit number that is AB. It is made up of digits A and B. And this number AB can be written as 10 into A plus B. So this is known as the general form of a number AB. So if a number that we have, a two-digit number we have is AB, then that AB can be written in its general form as 10 into A plus B. Here 10 because A is on the tens place while B is at the units place, therefore B is multiplied here with 1. Or similarly, you can write it as, you can write it as B. Therefore 10A plus B. Now any three-digit number ABC made up of digits A, B and C. How can a three-digit number be written? Let's take for an example, we have a three-digit number ABC. It will be written at, because A is at hundreds place, so it will be written as 100 into A plus 10 into B plus 1 into C or directly plus C. That is 100A plus 10B plus C. So this form is known as general form of numbers. We have written general form of two-digit numbers and three-digit numbers. Let's proceed. Now you have to try these questions. It's given that we need to write these following numbers in generalized form. I'll do the first part for you and the second one. You have to do the other two parts yourself. So first number is 25. You know how it will be written here. A is 2 and B is 5. So just like the previous slide, you will write it as 10 into 2 plus 1 into 5 or directly 5. That is, you can write it also like 20 plus 5. You know 20 plus 5 gives us 25. Similarly for 73, you can write it as 10 into 7 plus 1 into 3 or 3. That is 70 plus 3. Now I have written these two-digit numbers for you. Now try the same for these three-digit numbers. It's very easy. Next again, now we are given the generalized form of the numbers and we have to write these numbers in their usual form. So it's just the reverse of what we did earlier. See, I'll do this second part for you. I'll do the second part for you and do the first and the third part yourself. See, we have 100 into 7 plus 10 into 1 plus 8. So we have this. This is the generalized form of a number. How can the number be written in the usual form from this? So 100 into 7 gives us 700. Further 10 into 1 gives us 10 plus 8. You can easily add this and you will get, you can do it in your rough work as well or mentally if you're able to. I'll show you how. You will be writing it like this. You will add these numbers and you're getting 718. So what is our number? In the second part, our number was 718. And even if you try writing this number in the generalized form, you will get this form because 8 will be multiplied with 1 because it is at the units place. 1 is at the tens place, so it will be multiplied by 10 just like here. And further 7 will be multiplied with 100. That was given. So this is how you write the numbers in the usual form from their generalized form. Next we have games with numbers. Very interesting. It's the part 1. In the next lecture, we will do the part 2 related to it. So first of all, we have reversing the digits for a two-digit number. So if we have a two-digit number, you can choose any two-digit number. Our step 1 is choose any two-digit number. Step 2 includes reversing the digits. When you reverse the digits, you will get a new number. Step 3 includes adding these two numbers together. That is the original number and this new number that we got after reversing the digits. We add these two numbers together and the last step is dividing their sum. The sum that we got by adding these two numbers, we are at last going to divide that sum by the number 11. And what will you see? The result will be that the division will not have a remainder. Our remainder will come to be 0. R will be equal to, that is remainder will be equal to 0. Let's see how. Let's do this first part. It's written that check what the result would have been if chosen numbers were as chosen below. So we are given that the chosen number, that the first step is done. Chosen number is 27. It is a 2-digit number. What is our second step? First step is done for the first part, right? So second step was to reverse the digits. When you reverse the digit, you get a new number as 72. Third step was to add these two numbers. So what do you get if you add 72 with 27? You get 99. And what was our last step? Last step was to divide the sum with number 11. When you divide, you will see that you will get the quotient as 9 and your remainder is 0. So yes, this is true. This result is true that the division is not having any remainder because 99 can be divided by 11 and our quotient is coming to be 9. Similarly, if you will do this for these 39, 64, 17, try these yourself, you will get the same thing, that at the last you will get your remainder as 0. Now let's see, why does this happen? What is the logic behind this? Now see, if the number chosen is AB, we are taking it in this form. We have the chosen number, 2-digit number as AB. AB can be written in the generalized form as 10A plus B. Now on reversing the digit, what you will get? BA, and BA can be written as 10B plus A. Now because B is at the tens place and A is at the ones place. Earlier A was at the tens place and B was at the ones place. Now when we add these two numbers, let's just see what happens. We will add 10A plus B with 10B plus A and we will get 11A plus 11B, or we can take 11 common and we're getting A plus B. So we can conclude from here that the sum is always a multiple of 11. You can see that 11 we can take common from the whole sum. And yes, that sum is always a multiple of 11. So when we will divide this sum by 11, our quotient will be this thing. A plus B will be our quotient, which is exactly the sum of the digits of chosen number. And what will our quotient be? One more thing we can conclude, that our quotient will be, just a second, our quotient Q in such cases will be the sum of those digits A plus B. Here you can check 2 plus 7, yes, 9 was our quotient. So we have concluded these two things, that the sum will be a multiple of 11 and our quotient will be the sum of these two digits A plus B. What do we have next? Now we have one more thing, reversing the digits, 2-digit number. Step 1 will be just like the previous one, choosing a 2-digit number. Step 2 will be reversing the digits to get a new number, just like the previous method. Now step 3 is not to add these numbers but to subtract the smaller number from the larger number. So when we are taking a 2-digit number, we are reversing the digits, there will be one number that will be lesser than the other. And we are going to subtract that smaller number from the larger one. And the last step is dividing the result. The result that we will get after subtracting the smaller from the bigger number, we are going to divide that result by 9. And what will you conclude? What the result will be? That the division will not have a remainder. Again, our remainder will come to be 0 in such a case as well. Let's see. Now check what the result would have been if chosen numbers were as shown below. So first number is 17. First step was to take a 2-digit number. So we are given 17. Our second step was to just reverse the digits. I got 71. Third step now is to subtract the smaller number from the bigger one. So I'll be subtracting 17 from 71. And here it will be 6 and 11 and it's 4 and 5. So I'm getting the result as 54. What was our last step? Our last step was to try dividing this result by 9. So if you see that when I divide 54 by 9, I am getting the quotient as 6. And the remainder will be 0 because 54 gets totally divided by 9. And we are not getting any remainder. The remainder is 0. Yes, that is what we saw. That is what we learned from the previous slide. That the division in such a case will have 0 remainder. That is what is coming. Please try these 3 parts yourself and check after doing all these steps, what are you getting? Is your remainder 0 or not? Now let's see why does this happen. Now see if the number chosen is AB. Let that number chosen be AB. We will write AB in the general form as 10A plus B. On reversing the digit, we are getting BA. Again, 10B plus A. Now if the tens digit is larger than the 1 digit, that is first case is if A is greater than B. We will be taking 3 cases here. Now first case is A greater than B. Now if A is greater than B, when we subtract these two numbers, 10A plus B minus 10B plus A, we will get 10A plus B minus 10B minus A. On solving, we are getting 9A minus 9B. From where you can take 9 as common and you will get 9 into A minus B. So first is this case when A will be greater than B. Right? Now take the next case in which B will be greater than A. So in our second case, B is greater than A. In such a case, you will subtract 10B plus A. You will do this calculation as 10B plus A minus 10A plus B. Why? Because B is greater now. And you will again get 9 as common and in the brackets B minus A. Now let's see our last case also. So in our last case, we are taking both these digits A and B equal. So in a case, it's very obvious, then the difference will be 0. If A is equal to B, in the third case, we are getting the difference as 0. So in each case, what have you seen? What is the result? The resulting number is always divisible by 9. Either it's 9 into A minus B or 9 into B minus A or directly 0. All these results are divisible by 9. Just see 0, 9 into B minus A and 9 into A minus B. All these can be divided by 9. So you can see that on dividing the result by 9, the quotient is either A minus B or B minus A. Either A minus B or B minus A. Accordingly, as A is greater than B or A is less than B. On that depends that whether we will get the quotient as A minus B or B minus A. You can see from here the example that I did. What was that example? Just see, it was 17. So what remainder I was getting 6. Yes, that is 7 minus 1. So yes, we have the quotient was coming to be 6, and that is what in such cases our quotient will be A minus B, or I will write B minus A. That depends on which digit is bigger than the other. Either A is greater than B or B is greater than A. So that is how we have seen that what the quotient and what our remainder will be. So this was all about this video lecture. In the next video lecture, we will be learning about some more games with numbers. That will be our part 2. I'll meet you all in the next video. Till then, bye bye.